Hi, this is Richard C. I'm a math tutor here at Wyzant, and I'm answering a question that was submitted by a student. This is a question that you're very unlikely to see anywhere outside of a very challenging honors geometry course or perhaps a math competition of some sort. I've never seen this on an SAT or an ACT, so this one is just kind of for fun here, intellectual curiosity or what have you. It has to do with properties of what's called the incenter of a triangle. And incenter, the definition of an incenter, oops, having a little trouble manipulating this. The definition of an incenter, all right, I'll just leave it there. Definition of an incenter is the intersection of the angle bisectors. Now we have a 3, 4, 5 right triangle, and let me get those amounts in there. So this is our R3. That's a terrible 3, 4, 5 right triangle. And if you imagine drawing the bisectors of each of the angles, and that kind of looks like an angle bisector there. And then this would be another angle bisector here. Let's pretend they meet there. And then this angle bisector here. The intersection of those angle bisectors is called the incenter. So now that we've discovered the definition of the incenter, we're going to use some properties of the incenter as well. So the property that you need to know of the incenter is simply that, oh, no, I need to add a circle. So if we were to inscribe a circle using that as the center of the circle, let me get a circle here now. So here's the center of my circle, and now I'll just try to make it. That's not so great, but let's see if I can move it. I didn't. I'm able to move the whole thing, but I'm not able to move that circle. And when I do move it, I'm moving the triangle. Okay. Okay, so I'm going to have to try to get rid of that circle and do another one. Okay. Sorry about these technical issues here. So I think I'm just going to try to draw one that looks like it would be about right. And of course I can't, draw these to scale anyway. There we go. I actually grabbed it. Okay, so let's pretend that's the center of the circle, and I'm going to have to take this a bit like that. You're just going to have to imagine that there are points of intersection here. So here's the center of our circle. Sorry, these drawing tools are pretty good, but I'm not such a great artist here. So that's our incenter. These are angle bisectors here, here, and here. And a property that we are going to use here is if you drop the perpendicular like that, you can drop a perpendicular from the incenter. And those are all going to be congruent. They're all going to be equal to the radius of the circle. So you have to imagine the radius of the circle extending out to touch this leg here, and then the radius of the circle extending out to touch this leg here, and then touch this leg here. So you do have to use your imagination a little bit. Now, if you notice here, we have a radius and a radius, so we have a four-sided figure, and these are right angles, and so this is obviously a square, so we can fill that in with R and R. And now we can fill this segment, this line segment here, with 3 minus R. And we can fill in this line segment with 4 minus R, because the entire length is 4, from here to here is R, so that has to be 4 minus R. Okay. So let's use the angle bisector. I'm going to change color now. So this is our angle bisector here, and we do have right angles here and here. And these two right triangles are congruent from angle, side. So you have an angle, side. The two radii, of course, are congruent. So we have two congruent right triangles here because this is an angle bisector. So this gives us angle, side. Or if you go the other way, it's going to give you angle, side here. So if that's 4 minus R, that must also be 4 minus R. And then this has to be, the whole thing is 5, so this has to be 5 minus 4 minus R. And that's going to be equal to 1 plus R. Okay, because 5 minus 4 is 1, and then negative R is plus R. So now we're just going to set up an equation here. 3 minus R has to be equal to 1 plus R. So bring over the negative R, you get 2R here. Bring over the 1, you get 2 here. So the radius of the circle is 1. And so they want to know the area of the circle, which is going to be pi R squared. So it's just going to be pi. And that's it. So there's a lot of things you could do. You could try whatever. There's a couple of other solutions posted at Wyzant. But I wanted to do it. I wanted to do this because it's not quite as hard as it needs, as you might think it would be, and it is a question of memorizing the properties of the incenter. Now, you generally do have to memorize those properties, even in a, let's say a medium level honors class. But to go out and solve it using the properties and solve this problem, it's pretty advanced. So I just thought we'd do this one for fun. I hope you got something out of it, and I'll see you again next time. Bye-bye.